Hello, hello, hello. Wherever you are in the world, I want to welcome you to our webinar in the latest Accelerate Solutions, Accelerate Success series. Sorry, that was a lot of accelerates, but I'm feeling very accelerated myself in terms of energy and excitement because this is a topic that I love, finding out about how to actually optimize my games and my projects. My name is Andrew Parsons. I'm the product marketing lead for the Unity editor and engine. My specialty is in programming and performance. My background is 15 years as a programmer, 15 years on the dark side of marketing and advocacy to help developers create games. Been helping people make games for quite a while now, and I love every single minute of it. I love every single person I've worked with, and it's been just a wild ride. Do what you love, right? Anyway, we're not here to talk about me. We're here to talk about Patrick, and more specifically about his interest and specialty and understanding about optimizing your game by utilizing this thing called addressables, which helps you minimize build size and makes your projects run more efficiently. Patrick is part of our Accelerate Solutions team. He's worked on some great games and helped customers be successful in converting games from one platform to another. I encourage you to check out our previous blog post interview with Patrick on a conversion he did to a different platform. That's a really great read. And so welcome, Patrick. Say hello.
Thank you very much, Andrew.
Now, this is a little different from a normal webinar that I would moderate, where I would have a group and I'd be facilitating questions. What we're actually going to do is I'm going to pass it over to Patrick, let him introduce himself a bit more, and then he's going to talk you through the technical side of addressables, and then we'll come back for the questions at the end. Patrick, I'm going to hand over to you. Good luck, my man.
Thanks so much, Andrew. I'm very excited to be here today. So as Andrew said, we're going to talk about addressables and how it's going to help you reduce your build size and improve memory. So I'm Patrick DeVarney. I'm a senior software development consultant at Unity, and I'm part of the Accelerate Solutions games team. So what this means is I'm an engineer on a team, and we help customers, game developers that are working on all different kinds of games on all different kinds of platforms. And we help those customers solve technical challenges. And that could be anything from project architecture and editor workflows, porting between platforms, and we do a lot of optimizations. So engineers on our team, we try and kind of be jack of all trades and try and know everything that's in and around Unity. And a lot of that comes back to optimization, CPU time, GPU time, loading times, all kinds of stuff. So along the way, I've been using addressables a lot on a lot of different game projects. And I'm excited to be here today to show you guys some tips and tricks and some technical knowledge I've gained along the way that help me improve other customers' projects, and hopefully it can help you improve the projects you're working on. So we're going to start off today with a brief addressables introduction so we can understand what is addressables and why you might want to use it. We're going to look at some common performance problems, how you identify them, how you fix them. And along the way, we're going to be exposed to a couple of different profiling tools, including Unity Memory Profiler, the Addressables Analyze window, and Unity Data Tools. So Addressables is an asset management system for organizing, packaging, and loading content. And as we explore these slides, we'll get into more detail of what this actually means in practice. So why would you want to be using addressables? Well, you may have shown up today and you may have been doing some Googling and came across addressables or asset bundles, and it probably came from you're trying to reduce memory in your game. So addressables helps improve your runtime memory by delaying loading your content until you need it. So rather than you load up your scene and everything's loaded immediately up front, we can delay loading stuff until we're going to spawn it, until we actually need those heavy assets in memory. Addressables also has automatic memory management with built-in reference counting. So along with loading our content when we need it, that content can also be unloaded when we don't need it anymore. And lastly, addressables offers some improved visibility on what's going inside of your build. So you probably have a Unity project, it might be 100 gigabytes or hundreds of gigabytes, but your actual build is probably a lot smaller. There's a lot of prototype content. You might want to make sure that that's not leaking into your build. So to explore addressables and lay the groundwork for understanding, I'm going to use this small example project, and I've linked to a blog post here too that uses the same example project. So this example game is some sword and sorcery contrived example. And we have a spawner that spawns our inventory items. In this case, our game has 3 items. There's a sword for the player, there's this glowing red fancy boss sword, and there's this shield. And at runtime, we may need to spawn some of these items, and sometimes we might not need them. They might not be visible. It might depend on what the player has equipped or what kind of enemies we're fighting at the time. So we're going to look at how this impacts memory, and we're going to start off with no addressables implementation. We're going to start off really simply. We have a component, this inventory system, inside of our scene file. And this component has an array of game objects. And these are references to our prefabs in our project. So we have our sword prefab, boss sword prefab, and shield prefab. And these game object references can be referred to as direct or hard references. And we're going to look at how these direct references can have a negative impact on memory and why implementing addressables is going to address that. No pun intended. So we're going to take a look at memory with this initial example. We're going to build and run the game, and then we're going to download the Unity Memory Profiler package available from Package Manager. We're then going to attach the Unity Memory Profiler to our built game and take a capture. And then we're going to open that capture to see what was in memory at that exact point in time. And it's good to note that memory in the editor is different from the build. While you can take memory captures of the game running in the editor itself, you're probably going to get a lot of noise and a lot of overhead. You might see assets that are used by the editor itself that wouldn't appear in your game. So whenever you're doing any kind of profiling, be it memory or CPU, we recommend attaching to a built game. So then you're profiling what your players and your players' devices are going to be experiencing. So over here, I have the memory profiler window open in the editor. And in the lower left highlighted, we can see we have one memory capture loaded. You can note from the screenshot that was taken from the memory capture, I don't have any of the items spawned yet. I haven't spawned in the swords, haven't spawned in the shields. Nothing was needed by gameplay at this point in time. On the right side, we can see a list of all of our Unity objects sorted by type. And I've opened up the texture 2D category to show all of our textures that are currently in memory. And looking at the top of the list, we can see that all of our sword and shield textures are already in memory. Starting from the top, we have our small shield _M, our metallic texture, the sword normal texture, more sword and shield textures. So even though we haven't spawned anything, nothing's visible, we're not using the sword and shield, everything is currently in memory. And if we went to other categories like meshes or maybe audio files, everything for the sword and shields would also be loaded. And this is because when we load our scene, everything the scene references also gets pulled into memory immediately. So this current setup wouldn't scale very well. Maybe if our game needed hundreds or thousands of inventory items, we would be paying a really large memory cost because we have to load all that stuff immediately. And we don't want that. So how do we reduce memory? We're going to use addressables. That's why we're here. So we're going to swap, we're going to put our prefabs into addressables, and we're going to swap our spawner to load from addressables rather than just spawning from direct game objects. So on the right side, in the addressables groups window, I've created a new group called inventory items, and I've simply just dragged my 3 prefabs inside of this group. So I have my boss sword, my sword, and my shield. I then just make a couple small changes to my spawner script to use an array of asset references rather than an array of game objects. And these asset references are going to be the key to getting our memory improvements. So if we go back to the inspector after making those changes, things will look more or less the same initially. We still have an array of objects, and these look like they're prefabs. They look like they're just pointing to our assets in our project. But if we click the drop down to select a new asset, we can see that we're limited to only selecting addressables assets. So it's really important to note that this is an array of asset references. This is not an array of game objects. So what is an asset reference and why does it actually matter? So an asset reference just stores a hashed key. It doesn't store the actual asset itself. So we have a key that points to our shield prefab, but we're not actually storing the shield prefab. At runtime, we'll use that asset reference to pass off to addressables, and it'll load the actual asset that's associated with that. So asset references can be referred to as indirect or weak references rather than direct game object references. Our asset reference indirectly points to our shield, doesn't directly point to the shield. So when we load our scene, we're only going to pay the memory overhead of having those tiny little keys in memory. We're not going to pay the memory overhead of loading all the shield meshes, all our audio, all of our particle effects, everything. It's just these tiny little keys. So after making this change, we'll take another memory capture and see how things look. So now we have a second capture. Again, in the bottom left, we can see we haven't spawned anything. I don't have a sword. I don't have a shield, just empty scene. And if we look at the texture category, we can see that we don't have any sword and shield assets. We could then again go to our shaders or our meshes, and we're going to see those assets aren't loaded yet either, which is awesome. We could now have hundreds of inventory items referenced, and none of them are spawned until we actually need them. If we go ahead and spawn one of our swords, in the screenshot in the bottom left, we can see that just the sword loads. We have the sword normal texture and the sword diffuse texture. We haven't loaded the boss sword. We haven't loaded the shield. We haven't loaded our helmets and our armor, all of our other items. We just load the stuff that we need at this point in time. When we're done with the sword, we can tell Addressables to release it, and it'll then disappear from memory. So now we can scale the number of items we have. We can start converting all of our spawning systems. If you have something that spawns enemies or characters, you might want to convert that to addressables. So we've seen that by swapping our direct references to indirect references, we get a memory improvement. And assets are only loaded in memory when we call addressables to load that asset, either by instantiating it or saying load asset. When we're done with the asset, we just call addressables release, and then all those assets, all their dependencies released from memory. So we've seen that addressables handles automatically loading and unloading our assets from memory. But we can get improved performance by changing how we organize our addressables groups. So as you add content to your game and your game grows or changes, it can be kind of unclear on what assets you put into which group. And that can have a big impact on memory, and we're going to see build size too. So we're going to look at two common performance problems, how to identify them, how to fix them. So first, we're going to look at how to improve our memory performance even further. So at the beginning, we read Addressables is an asset management system for organizing, packaging, and loading content. But really all this means is Addressables is a tool for using asset bundles. Addressables builds asset bundles, downloads asset bundles, it loads asset bundles. Everything is asset bundles. So while Addressables uses asset bundles under the hood, and we don't have to directly interact with them, as the user, we have an asset reference to our shield. We don't have to know what asset bundle the shield is. We don't have to go find if we need to download the asset bundle. We just pass off the key to Addressables and say, hey, please load this shield. And Addressables handles everything from downloading the bundle, loading it, dependencies, all that nasty stuff. And it just hands back, here's the shield object, and that's great. So Addressables abstracts away asset bundles, but it's really useful to understand how asset bundles are built and how they function, because that's going to unlock a lot more performance improvements. So what's an asset bundle? An asset bundle is simply an archive file that contains non-code assets. That means it's a tiny piece of metadata along with some content, be it meshes, textures, shaders, all kinds of stuff. At build time, addressables groups create bundles. And our addressables group settings and what content we put into which groups are going to affect our bundles. And our bundles are going to affect our performance. So we really care about what's going into these bundles and where things are in our bundles. Some visuals are probably going to help here. So we'll go back to the same sword and shield example. On the far left side, we have our 3 prefabs sitting inside of our project, along with a bunch of other assets. We'll then drag those 3 prefabs into an addressables group. Then when we build addressables, groups become bundles. And by default, one group will create one bundle. So we end up with, on the far right, one bundle that has our 3 assets inside of it. But at runtime, the only thing that really matters is bundles. Runtime doesn't have a concept of addressables groups. Groups just inform how we make our bundles. So everything's about bundles. At build time, groups create bundles. At runtime, addressables loads content from bundles. So let's look at loading content with our previous example. At runtime, again, we only have bundles. Bundles are everything. It's all about bundles. So we start off, we have nothing loaded, signified in gray. We have a bundle with some assets in it. We'll then instantiate our sword because the player needs to equip it right now. So addressables will automatically load the bundle, and then it'll only load the asset that we wanted, the sword, and we'll increment the reference count to 1. We then don't need the sword anymore. Maybe the player dropped it and it despawned. We destroyed it. So we'll release the sword. The reference count for the sword goes back down to 0. And on the far right, we can see the sword and the bundle are now unloaded, which is awesome. That's what we wanted. But we might run into a case where assets aren't seeming to be unloaded, even though we've released them. And this is because of a tricky little nuance with asset bundles. So an addressables asset is released when both of these conditions are true. When the reference count for the asset itself is 0, and when the reference count for everything else in the bundle is also 0. And this is the important thing, this step number 2. Everything in the bundle has to have a reference count 0 for anything to be unloaded. So if we change what assets we loaded, we can run into a little bit of a problem here. Again, on the left, we'll start, we have nothing loaded. We'll then spawn our player and it needs its sword. So we'll spawn in the sword. And then the sword's going to fight the big boss now. So we'll also spawn in the boss sword. So in the middle, our sword prefab and our boss sword prefab both have a reference count of 1. We've spawned them 1 time. Then the player fights the boss and defeats the boss. The sword disappears. We don't need it anymore. And we say, please release the boss sword. On the far right, the boss sword reference count goes down to 0, but we can see it's still loaded in memory. This is because everything in the bundle has to have a reference count of 0 to unload anything. And we can't unload the boss sword because the sword prefab still has a reference count of 0. So we can run into a problem where we have partially loaded bundles that have assets that are still sticking around because they start becoming dependent on each other. So from this, we can see Addressables does support partially loading asset bundles. We were able to successfully load our swords without also loading our shield, which is awesome. But Addressables does not support partially unloading asset bundles. Everything's dependent on each other as long as it's in the same bundle. So we're going to look at how we can change our bundle layout to help these inventory items automatically unload from memory. So instead of having one addressables group create one asset bundle, we can have one addressables group create multiple bundles. So we put our 3 objects inside one group, and we could change this group's settings to pack all of our assets separately. So we end up with independent bundles with our inventory items. So now by placing our swords in 2 different bundles, we can unload them independently. And this will look something like this. So again, we start with nothing loaded, but now we have 3 independent bundles. And this is going to help us with the boss sword example. If we load our sword, we spawn it in, we load just the sword. We haven't loaded anything else. This is awesome. Then the player's going to fight the big boss. So we load in the boss sword. Everything still looks good. We still haven't loaded the shield, which is great. Then the player defeats the boss sword disappears. We then tell Addressables to unload the boss sword. And now we can see the boss sword was able to be unloaded. That's because it's not waiting on the other bundles to be unloaded. Everything inside the same bundle isn't used anymore, so everything gets unloaded. So we can make these independent bundles by just modifying one setting on our addressables group. So again, by default, one group will create one bundle, and that's controlled by the bundle mode, and it's set to pack together by default. Instead, we can just swap this to be packed separately, and that tells Addressables to pack every asset into its own bundle. So this way, if we had 100 inventory items in one group, we could end up with 100 individual bundles, and stuff can be loaded and unloaded dynamically without everything waiting for all of our inventory items in our whole game to be unloaded. So as a general rule, we should probably put assets in the same bundle if they're going to be loaded and unloaded at the same time. It can be kind of risky to have unrelated assets all in the same bundle because you might not know when they're going to be loaded and unloaded, and you'll have stuff sticking around in memory even though you don't need it. And as bundles grow larger and then become more general purpose, you have a higher chance of running into this partially loaded bundle problem. So initially in your game, maybe you have 4 characters and they have some textures and meshes associated with them. It might be pretty easy to dump all 4 characters into one bundle, and that might work fine for a while. But as you add more characters into your game and more content, those characters become dependent upon other assets, It becomes more risky as you spawn and despawn characters. The ones you despawned might still be in memory because everything becomes dependent. So to find these problematic assets, there's two tools that are really useful. The Unity Memory Profiler, which we looked at before, and a little bit of gameplay knowledge can help you point to suspicious assets. So if you take a memory capture and you see probably start with some heavy assets, look for shaders or textures or meshes that you don't need anymore. We know we don't need that boss sword, but we see the boss sword emissive texture is still sitting in memory. Find those suspicious assets, map them back to the bundles they came from and the groups they came from, and then try and reorganize those assets so they get unloaded automatically. And if you're on Unity 2022 or newer, you can look forward to the upcoming Addressables Profiler module, which makes this workflow a whole lot easier. This is going to be really cool. So the new Addressables Profiler module can be added to the Unity Profiler, which is included with Unity. And like I said, this makes the workflow a whole lot easier than using the memory profiler. So on the bottom left, we get a list of all of our bundles that are currently loaded. So in this case, there's a cube assets bundle, some settings, Unity Chan, a bunch of bundles. Inside each bundle, we can see what assets have been loaded. So for the cube assets bundle, 4 assets are currently in memory. There could be other assets that are inside this bundle, but there are only 4 that are loaded in memory right now. Looking at the first 3, we can see that their names are in dark gray, and we can see that their status is listed as released. This means that we don't need these assets anymore. The reference count is 0, but they're still in memory. This is like the boss sword in the previous example. And we can see why they're still in memory. The last item in the bundle that's loaded is the Unity logo.png texture file. And we can see this is light gray and is listed as active. So we either loaded the Unity logo, or there's another bundle that's dependent upon this logo and needs it still in memory. And because of that logo, all of our other assets in this bundle can't be unloaded. So if you use this profiler module in your own game, you could find there might be groups of similar assets that are released that want to get out of memory, but they can't. You could take those released assets and put them in their own bundle so they get unloaded automatically. So we've looked at improving memory even more by adjusting our group settings. And next, we're going to look at how we can get you guys some big build size improvements by also just adjusting our addressables groups. So as projects get larger and we get more content, it can become a bit harder to organize all of our groups. When you start with a small game jam project, maybe it's easy to put each character in its own bundle, but things will easily get out of hand when you start having hundreds of gigabytes of assets. So we're going to look at adjusting our bundle layout to help with build size in these complicated situations. So for this one, we're going to switch up examples. I'm going to use the Unity Boat Attack sample project. And this is a third-person water racing game in a tropical environment. So we're going to go over to my addressables groups for this project. And I have a couple groups set up to organize my content. I have a boats group, a group for my UI, and I have 2 groups for my levels. So in this version of the game, there are 2 scenes the player can race in, but they'll only race in one at a time. So they can either race in the level island scene, or they could race in the level island 2 scene. So it's good to note that these 2 Unity scenes are different files on disk, but they share a lot of the same content. They're both water scenes. They both have the same palm trees and rocks and tropical birds and everything. Just a different layout of the race course for players to race on. So if we build our content, we end up with about 500 megabytes on disk. This is building for PC. But what was actually built, and can we reduce this size? We can view our bundles on disk. So if you build your addressables content while you're in the editor, it'll end up in your library folder, which is where these are. But if you build your content for a built game, it'll end up somewhere in your data streaming assets folder. So here we can see I have the default settings because I ended up with 1 bundle for each group. Starting from the top, we have a boats bundle, level island bundle, level island 2, UI, and so on. Looking at the sizes on the far right, we can see most of the content is stored in my 2 different scenes, about 250 megabytes. And it's kind of suspicious that both of my scene bundles are almost exactly the same size. But from this, we still can't see what actually made it into the bundles. We need another tool. So we're going to look at Unity Data Tools to analyze our build bundles. So this is a small tool available for free on GitHub, and it's a simple command line interface that simply outputs a database file. It's nothing too scary. So if you download this tool from GitHub, simply open a command window, navigate to the tool, and you just need to pass it two things. On the bottom, I've passed it the directory for where my bundles are, which we can see is my data streaming assets folder. And I like to use the -o optional output file name. So my database file automatically gets named to something. If I'm going to be building bundles a couple of times and I want to output different database files. So I've named my file botattackbundles.db. So we run this command. It'll run pretty fast, even if you have gigabytes of data, probably under a minute to analyze all your content. It's really good for iteration. And when we output the database file, we need to open it to actually look at it. So here's the big scary slide with lots of data. But it's fairly easy to read once you know what you're looking at. So I've opened the database file in DB browser for SQLite. This again is free software you can download, and it simply browses .db files. So when we ran Unity Data Tools, the analyze command, it helps us out by making a bunch of automatic tables to sort all the content that's inside our bundles. So on the top left, there's a table drop down, and we can look at all of our meshes and all of their settings. We could look at all of their textures. We could look at all of our audio files. There's a lot of different tables here that can give you a lot of optimizations for finding suspicious texture sizes or things like that. But for this example, I'm specifically interested in the view potential duplicates table. So this table we're looking at with a lot of different rows is showing all of our assets that might be duplicates between multiple bundles. So if we look at the first row, we can see we have two instances of this cave default matte base curvature texture. We have two cave textures, and these cave textures have the same name, they have the same type, they're both texture 2D, and they have exactly the same size. They're both about 21 megabytes. So they're a suspected duplicate. On the far right, we have a list of all the bundles that this cave texture was in. We can see it was in the Level Island 2 bundle, and it was also inside the Level Island bundle. So we have two copies of this texture on disk. So we're at least paying twice the disk size for this texture. And at runtime, we could be paying twice the memory size. So in our game, you can only load one scene at a time. You can either race in level 1 or level 2. But if for some reason we could load both of these scenes at the same time, we would have two copies of this cave texture, taking up twice as much memory and also twice as much disk size. So we want to get rid of these duplicates because we could get memory improvements. We're definitely getting build size improvements, which could also impact loading size, patch sizes, all kinds of things. We want to get rid of these duplicates. So we found a problem, but we need to understand how we got here. How did we get two copies of this texture? And that's going to point to how we fix this problem. So we started off, we had one addressables group with our Level Island scene. That's going to make one bundle with our scene in it. But our scene isn't the only asset that is needed to get the job done. Our scene depends upon a lot of other stuff so that it can show all the pretty pictures. So our scene is dependent upon a palm tree prefab that has palm tree textures. We have rock meshes, we have water shaders. There's a lot of other content that scene also needs to do its job. So all these dependencies are called implicit assets, and the scene is an explicit asset. We explicitly added it to the group. Everything else is just implicitly being dragged in. So to go over the vocab again, explicit assets are assets that we manually add to addressables groups. Everything you see in the addressables groups window is an explicit asset. And implicit assets are dependencies that had to be automatically also pulled into those bundles. So at build time, we're going to run through this process and have some visuals after this to make more sense of it also. So a group is going to create a bundle. We're going to take all the explicit assets and we're going to dump them in that bundle. Then we're going to look at all the dependencies, all the other stuff that those assets need. For each dependency, if it exists somewhere else in addressables explicitly, we'll do nothing. But for each of those dependencies that doesn't exist already, we're going to implicitly pull it into that bundle. And here we'll see how that caused a problem with our two scenes. So we had two different groups, one with each of our scenes. We create two bundles, and we know that we need to include all the explicit assets in the bundle. So we dump the Level Island scene and Love Island 2 scene into their own bundles. Then we'll start going through all the dependencies, everything else this scene needs to do its job. So this scene is dependent upon the palm tree prefab. We'll check, is the palm tree prefab explicitly declared somewhere else in addressables? In this case, it wasn't, so we pull the palm tree into this bundle. We then go through the palm tree textures, we go through a bunch of meshes, everything else. We're pulling in a lot of content into this bundle. It's getting really big. Then we're going to run into a problem when we go to build our second bundle. We'll start going through dependencies, and we're going to hit the same thing. We look at the palm tree prefab. Is the palm tree prefab explicitly declared somewhere else in addressables? It is included in bundle number 1, but it's not explicitly included. So it gets implicitly pulled in to bundle number 2. So now we have our first scene and we pulled in all these dependencies. This bundle got really big. Then we go to the second scene, and we pull in tons more dependencies, and it's also getting really big. And we end up with a lot of duplicated content because, again, these two scenes happen to share a lot of the same things. They're the same tropical environment. They depend on the same stuff. And because those assets didn't already exist somewhere, they get implicitly duplicated. So let's look at how to fix this. So luckily, we don't have to do all the heavy lifting ourselves. Addressables has some built-in tools to help us out. So there is, in the editor, an Addressables Analyze window that has a couple analyze rules to help point out potential problems with our bundle layout. So we're going to look at the check duplicate bundle dependencies rule to find all of these duplications, and it'll have a fix operation to solve this problem for us. So if we run this rule, it'll simulate building bundles, and it's going to look for that implicit asset duplication, find all those assets that had the same name that ended up in multiple bundles. So in this case, it gives us a list. There are 3 groups that have asset duplication: boats, Level Island 2. And I sometimes find it's useful to actually invert this list. So we get a list of assets rather than a list of groups. So I'll invert the list, and we get a list of each asset and what bundles it ended up with in. So if we take a look at the first one, we can see we have a water splashes texture file, and it was included in 3 different bundles. So we're paying 3 times the disk space for this particular texture. If you look at other items in the list, we can see some of them are duplicated twice, some of them are duplicated 3 times. There's a lot of content that's being duplicated that we don't want. But it would be kind of a pain to have to drag each of these assets and put them in addressables groups and sort that out ourselves. So there's an automated fix operation we can run to at least get us started in the right direction. So if we press fix selected rules, it'll help us out by solving this duplication. And if we bounce back to addressables groups, we can see how it went about solving this. So a new group was automatically created called duplicate asset isolation. And then that rule went through the whole list of everything it found that was duplicated and just dumps it all into this one giant group. So now when we go to build our scenes, they're going to successfully find that all of our assets, all the dependencies were explicitly declared somewhere else in addressables. So it doesn't need to pull in the palm tree prefab. It already exists. It doesn't need to pull in the water meshes and the water shaders. They already exist here in this big group. So our bundle layout is going to look something like this. We go to build our Level Island bundle. We put all the explicit assets in it and put the Unity scene. It's going to check, is the palm tree prefab somewhere in addressables? And it is. It's now explicitly declared in our deduplication group. Then we go to build Level Island 2. And again, all the dependencies are already there, which is awesome. We don't need to chunk everything into our scene bundle. And then we build our duplicate asset isolation group, and we end up with all the shared dependencies in one go. So if we rebuild all of our addressables content and we check it out on disk, things are looking a lot nicer already. We can see that both of our island scene bundles are a lot smaller. We went from about 250 megabytes down to 24, which is a pretty big win. And we can see we have a new bundle also, duplicate asset isolation, which now stores most of our content. And this is the content that's shared between our Level Island scenes. And we could see there was some content that was also shared with the boats bundle. So comparing to our previous build, this is a pretty big win for not a lot of effort. We started with 500 megabytes and we ended up with about 300 megabytes of size on disk. So we got about a 40% reduction purely by just changing our bundle layout. It's important to note that we didn't change any content. We didn't remove any content. We didn't reduce texture sizes. We didn't have to sacrifice any quality of our game or make any code changes. We just adjusted what content was in which bundle, which gave us a better layout on disk. And again, these performance improvements can go to other areas as well. If we were to load our boats and our islands at the same time, we don't have that water texture duplicated in memory. So we have a memory improvement. We also don't have to load as much content from disk. So we have a loading time improvement. If you have patch sizes for your players you're worried about, this is going to reduce that as well. So the big takeaways, bundle layout is really important. Again, Addressables is just a tool for using bundles, and knowing how bundles work is really important for getting all these performance improvements. And unfortunately, Addressables doesn't have a one-size-fits-all solution for bundle layout. There's not just a magic button you can press that'll put everything in the optimal layout. You need to use your gameplay knowledge about when you're using assets, when you need to load them and unload them, to sort things accordingly to get the best memory and build size improvements. So understanding how asset bundles work under the hood and understanding the vocabulary here of explicit, implicit assets is going to help inform how you lay out your bundles. So how can you be successful? The first step is just move your content to Addressables. By being in Addressables, you're already going to get those memory size improvements. Next is understand how asset bundles work. Know the difference between direct references and indirect asset references and how that gets you a memory improvement. And then understand explicit versus implicit, because that's going to get you the build size improvements. You can build a couple times, look in the Addressables analyze window, see how things are getting duplicated, and iterate a little bit to find the right layout. Then understand how to profile these problems. Use the tools that you have available to you. Unity data tools, if you're on new Unity, again, use the Unity Addressables profiler module that's coming up. Makes this workflow really nice. And try and figure out how to move that content so Addressables can automatically unload it. And lastly is just keep iterating. You don't have to get it right the first time. This is a complicated problem and it requires a lot of gameplay specific knowledge again. But if you have your content in Addressables and you understand these rules, do some profiling and just move stuff around between groups to try and have that stuff automatically unload. Yeah. Thanks for having me. And we'll go over to Q&A now.
We have quite a few questions, Patrick. I don't know if you're.
There's a few, yeah.
There's like been like 60 odd questions. We're not going to get to them all. So I do want to actually remind people that we will look at any questions that weren't answered during the thing. And if appropriate, we'll try and post answers probably in the Addressables forum. But right now I want to start with those questions. I know a few people ask questions about dots, and I will answer that one, Patrick. Just dots is near and dear to my heart. We have ECS for Unity 1.0 is being released alongside 22 LTS. You can already start using it as part of 22 text stream, 22.2. And so the questions about do Addressables and dots work together? Yes. With ECS for Unity 1.0, there is a content manager, and that makes Addressables possible in an ECS-based project. So that should answer the 3 questions around dots in terms of, does it actually work? Yes, that's how you do it. You have to use dots 1.0 or ECS 1.0, and you'll be there. So Patrick, let's start trying to answer some of these questions. I'm going to ask you Addressables friends questions first. I've got object pooling and Addressables. Are they best friends?
Yeah, they can absolutely work hand in hand. So the way you would go about that is if you need to start up your object pool, if we're going to need to spawn a bunch of projectiles or something. Mm-hmm. So you have a prefab of your projectile, you have it in an asset bundle, and you need to create the pool. You'll load it from Addressables once, and then you'll spawn a bunch of copies of it. And so now you have it loaded in memory, and you can do your normal object pooling. You could have your list or collection of game objects and do it just the same way you would normally. And the only extra bit is just when you unload that projectile. You're just going to tell Addressables, hey, I'm done with this, and you'll release that one instance of that projectile. So you don't need to keep track of every single projectile. Addressables will give you a handle saying, hey, you asked for this asset. You keep a hold of that handle until you're ready to release it. So you're like, hey, I need to create my pool, create one handle, spawn as many times as you want. We're done with the pool, give the handle back to Addressables, and it'll handle unloading everything.
Awesome. So now I'm going to ask you about another potential friend, but it sounds like it's going to be the other way around. TextMeshPro and Addressables, not best friends.
Possibly not best friends by default. I'm actually running through swapping some stuff to TextMeshPro with Addressables right now. There's a lot of good form advice from our engineer, Stefan, who created TextMeshPro, and he's actually on the same team I'm on now. So I actually asked him for advice on this too. So by default, TextMeshPro doesn't use Addressables, but I would say it's a friend. You just have to put a little extra effort into it. So you'll have a, forgetting the name of the asset, there's a TextMeshPro like global settings asset that points to like your fallback fonts. So if a character doesn't appear in the font you've chosen for a UI, you'll fall back to all these other fonts. And when you boot up the game, that global asset is immediately loaded, and it loads all those fonts into memory, which could take up a lot of space. Mm-hmm. But a little trick you can do is you could have just like one fallback font, and later on in your game, so you boot to your main menu, in the background, you could load additional fallback fonts from Addressables and then just slot those in to the global asset. So you don't need to load 30 megabytes of text content immediately. Just load like 3 megabytes. And then in the main menu in the background, while the player is selecting stuff, just start loading in those extra fonts and slot them in. So that could give you a nice boot time improvement.
There's a bunch of different questions about different platforms and genres. So I'm just going to sort of stream them all together, and then you can sort of answer how you like, Patrick. Does it make sense to use Addressables for WebGL? When we think about like remote stuff, streaming virtual textures in, does that work with Addressables? Does it make sense to use with Addressables? Have open world game with obviously lots of assets in lots of different areas that get pulled in. How do I manage multiple bundles and avoid using unload unused assets, which that is also asked a couple of different times. I'll pause there. I think that's a good enough set of questions to go together.
Sure, yeah. WebGL, well, we try and be jack of all trades at everything. I haven't interacted with WebGL yet. It's one of the remaining platforms. I've done everything from PlayStation 4, PlayStation 5 to Apple TV and all kinds of stuff. I haven't hit WebGL, so I don't know quite yet. That might be a question for the forums. About different genres and stuff. Yeah, open world does add some problems to it, but we can still solve it with our bundle layout. So we had a previous blog post talking about using Addressables with Subnautica that we worked on. And Subnautica, a big open world game, and the player could go to a lot of different environments. And the first thing you'd think is, for your open world game, maybe you have a forest biome, and we'll dump all the forest assets into the forest bundle. That's really cool. And then all the mountain assets go in the mountain bundle, and that's cool. But the problem you'll run into is the player will go to the mountain, you load a bunch of stuff, and then the player will pick up a rock or something from the mountain. They bring it down to the forest, and you want to unload the whole mountain, all the mountain meshes and stuff, but you can't because the player picked up one rock or they plucked a flower or something, and you can't unload it. So it ends up becoming this puzzle of trying to think of what assets could be loaded at any time. So anything the player could pick up could be loaded at any time. It could be in their inventory. So that stuff should probably be extracted. So maybe try and think of it as grouping like your mountain content that's like static, not like static meshes, just like if the player is in the mountain zone, this stays in the mountain zone. So what goes on in the mountain zone stays there, and you can't pull that out. But anything that's dynamic, like pickupables and stuff, you'll have to handle that differently, because that could, you'd run into the partially loaded bundle problem.
Yeah, actually, on that, something you and I talked about yesterday was that this is more an iterative process, right? Because part 2 of your talk had introduced part 1 problems, right? And so it's kind of like you do this initially, you assess, what things you can bundle, and then you do your optimization to dedupe the content. But then as you continue to build your game project, you need to probably go through those steps multiple times on a regular basis to ensure that you have the optimal.
Exactly, yeah, because if we, in our sample game, it's kind of easy to just deduplicate everything and dump it into one group and make one bundle. But if you were to take a large game that's a 500 megabyte Unity project and dedupe everything and just dump it in one bundle, that's probably just a good starting point, but not a good place to just run with forever, because you're simply just taking all assets that are duplicated and dumping them into one giant bundle, which then, as you said, Andrew, kind of feeds back into the partially loaded bundle problem. We now have this large bundle that has a bunch of unrelated content. It's great when it's just palm trees and tropical water and tropical birds, but if you just dedupe everything, yeah, everything's unrelated. So it might just be a first pass kind of thing. And then you go through those duplications and you find, okay, of all the duplications, this is stuff that's duplicated by a certain set of scenes. So let's pull that out and put its own thing. The remaining stuff, this is stuff that's duplicated by my characters. We'll make a shared characters shaders bundle and start cutting that down rather than just having random assets sitting in a giant bundle.
Yeah. So keep that in mind, team, as you're working on your projects, that this is not necessarily just something you do once, but you kind of want to do multiple times to have the best optimal outcome there. I want to ask you some possibly sort of technical questions behind the scenes, under the covers. Are bundles all loaded into memory all at once, or how do bundles get loaded in? Is there a predictive order of assets within a bundle that gets loaded? Like, isn't that?
Yeah, so an important distinction here is that when you load the bundle, that does not mean you load content from the bundle. So it's good to think of, you have your file on disk that we refer to as like the bundle. But when we tell Unity to load an asset bundle, we're really just loading the metadata that points to all the content in it. So we tell addressables, hey, load this one sword. That's the asset I want. Addressables, it would be correct to say addressables loads the bundle, but it would be incorrect to say addressables loads all the content from the bundle. It just loads the metadata. That's this little map file to point to these assets, and then it'll load the asset from it. Does that answer the question?
Yeah, I think so. And then with the metadata itself, does that get sizable or is it really minimal?
It's fairly minimal in most cases. So the metadata contains a mapping to the files in it, and the addressables catalog can also get kind of big. Handles sorting out all the dependencies. So this bundle depends on these assets. This asset depends on this. There's a big mapping file for it. So the addressables catalog can get large depending on how many bundles you have. So it wouldn't be a great idea to simply just have one bundle per asset for your entire project. That would be a lot of overhead. So the addressables catalog is going to get really big. And also, if you load a lot of bundles at the same time, you can start paying a little bit of a cost for the metadata, but that's a bit of an older problem. So if you're on a project that's older than Unity 2020, it's not good to have a lot of bundles loaded at the same time. But Unity 2020 and newer, 2020, we added a pooling system. So now you could load hundreds of asset bundles at the same time, and you don't pay a lot of memory overhead. There's not a cost per bundle anymore.
Awesome. I know we're almost at time, so but there are so many extra questions. Let me ask one really quickly. Oh, okay. What it was what's the overhead consideration for using only one asset in a bundle that has 5? Right. We just talked about the fact that when you load the bundle, you're only loading the metadata and then you're only loading in the things. But if the bundle itself is remote, like number one, you're going to have to download the whole bundle at that time, or does it only download the bit of the bundle?
I believe 90% confident if you have a remote bundle and you're dependent on it, you need to download the whole bundle. Right. Even if you just need a part of the content, you need to download everything. So if you're in a maybe a mobile game situation, you might want to err on the side of having more but smaller bundles. But again, you don't want to go too much to an extreme, and everything kind of feeds back into each other. If you made a lot of really tiny bundles on mobile, you might start running into IO speed problems or download speed problems. But it'll probably be a balance. And again, iterate on this, and you don't have to make content and code changes. You could do a setup being kind of conservative, having a few larger bundles, test it on mobile. How long does it take to download this stuff and load it into memory? And then you could go the opposite direction, try and be very aggressive and have a lot of really tiny bundles, and then do the same test. Can we get the player into gameplay faster this way? Like, how do we need to change this setup? for how large our bundles are.
Yeah, awesome. Do we still need a bootstrap scene to load the next scene using addressables, or is that?
Yes. So if you build something with Unity, you need at least one scene in your build settings. And if you're going to use addressables and you've converted a lot of your content over to addressables, our general recommendation is include one scene in build settings, and that scene should strictly just have a script in it that says load like the main menu from addressables and just start living in addressables land. So once you get to that point, you can move all your content over. It's going to be really nice because when you start mixing content, you can start having a different kind of duplication. So it's useful to think of content that's in addressables is in like one world, and content that's going into your player that's from build settings is a different world. So it would be not advantageous to have a main menu in build settings that has our palm tree and our rocks and stuff, and then have that same scene in addressables, because that content's going to be duplicated. And the only way to solve that is by bringing everything to addressables.
Yeah, awesome. Hey, Patrick, I'm going to ask you to reshare the screen so we can move on while we finish up. While you do that, yeah, let's go there. I want to mention this, give a shout out to Jeff, who's actually on this webinar paying attention to chat with you all. We've just published this today. It's all about, thinking about addressables and going into a bit more of a detail with some cheat sheets and stuff. Highly recommend that as well to go along with what we've just heard. I also want to highlight that we have an addressable specific forum. It's called, it's just bit.ly /forums addressables, capital F, capital A. Bit.ly is case sensitive. Use that and you can post your questions and you'll follow up from here if there are any questions we didn't answer that you did ask. There are some very, very specific detailed questions like using an animator and animation overrides and stuff like that. Like they're the kind of questions that please post in those forums because they might be edge cases that we want to look at specifically. So I just wanted to highlight those two resources for you. Also, check out Patrick's previous blog post on his conversion platforms using addressables. And I think that's it for that. Patrick, we have literally 60 seconds. So I want to say thank you. Thank you to all of you joining in. The more than 350 at one point. All the questions, all the chat was fantastic to spend this little bit of time with you from all around the world. Have a great rest of your evening or day, wherever you are. And Patrick, thank you for giving us such a great run through of how addressables works and some of the stuff that we can all use to make our games and projects more efficient. Do you have any last words?
No, just thanks for having me here. Thanks for all the help, Andrew, and thanks everyone for the questions. Sorry we don't have infinite time. It would be awesome to answer every question individually, but I hope this gives you guys the knowledge and some resources and some tools to help solve your problems out there in the wild and make your games run faster.
Great. Thanks, Patrick. And then Patrick's and my Twitter handles there on the screen. There's the Accelerate Solutions Games webpage. I highly recommend you check out. That's the Patrick the team belongs to. That's the team Patrick belongs to. My Mr. Andy Puppy handle will take you everywhere. It's my Xbox, PlayStation, all the other gaming profiles you can think of, Discord, etc. So feel free to reach me with all those things. We also have a Discord server. Highly recommend you engage with that. It's really lively and lots of people to help there as well. So thank you all. Have a great one. Goodbye.
Bye, everyone.